Here is this is about optics. Here we are dealing with the light. So then that this chapter belongs to the optics interference. How the light so its interference. That means that we can see the ripple when we throw the stone in any pond. There we can see the different types of ripple, and there you can see the mix of the light. Somewhere you can see upward displacement of a water molecule. Somewhere you can see downward displacement of a water while we throw any stone in a pond or in a river. Same the way you can see here in this figure. Somewhere you can see white fringe. That means white, white, white. That means bright fringe you can see. Somewhere you are seeing here dark fringe in a screen. So that here we are going to deal about uh, different light. Here is one of the light which is from the source as when the light from the source is allowed to incident on the slit A and the slit B, and these two ray of light when incident on in the screen we can observe two types of fringe. Somewhere we can see bright fringe, somewhere we can see dark fringe. So that here first of all Young's, it is the name of the scientist who first explained how the interference takes place in the in any experiment. Here is given about this, and he tells in this experiment, Young's double slit experiment, he first considered here. Let us consider he considered as his source of a light and a source of a monochromatic light because it emits the same frequency of a light. So we can say the monochromatic, and AB and are the two slit. You can see AB are the two slit which act as a coherent sources from which light is traveling and inserting, going inside. In between, this is the slit, this one is the screen. You can see it here figure, and dB the distance between two slit A and B. This D is a distance. Small d is distance between the slit slit A and B, and let a screen XY. You can see here XY as a screen, which is d distance from the source. Here is source S. You can see here this is a slit. From the slit, how much distance it is out? It is just d distance from slit. And the C with the central point, you can see here this C with the central point which is equal distance from the A and B. You can see this C which is at the center on the screen, and C is equal distance from CAAB, which is same as RC and CQ. So here is given that. And next is let P be the point x distance from the C. This P be the point x distance from the C at which the ray of light meet each other from the slit A and B. From these two slit, here is slit A, slit B. From these two slit, what are coming? Light are coming. When this ray of light reach at this point P, and they meet each other, at that time their path of travel, that is different than each other. When we compare them to each other, that means AP is not equal to BP, because BP ray of light travel more distance than the AP. So there we can see the path difference. First he calculated the path difference in between the two waves AP, suppose AP and BP. And he wrote here path difference equal to BP minus AP, because that much distance, BD distance, which is more than the AP, this BP wave travels. So we calculate here this part difference at here. The where BP square equal to BQ square plus PQ square. From this figure, BP square where is it given? Look at here, BP in the triangle BPCQ. When we apply Pythagoras theorem, then BQ square equal to BQ square plus PQ square, and substitute this value. The BQ equal to the D, because this capital D is distance between slit and the source. And when we apply this whatever value here is on this equation, we can get here BP square equal to D square plus x plus D by 2 is square. The PQ, where is PQ? PQ. Here C2P is x and C2Q is D by 2. So total distance from the PQ would be here D by 2 plus x. So I have written x plus D by 2 in the place of PQ, and here is square as it is what you see in the Pythagoras theorem. So this is from Pythagoras theorem we apply on the triangle PPQ. And the same the way again we apply the Pythagoras theorem in the triangle APR. We calculate this formula, Pythagoras theorem we apply and substitute whatever value. And when you subtract this AB square from the BB square, this is the distance travel from A to P. This is the distance travel from B to P. So that there is no same distance in between them. So there must be the part difference. So how much is part difference in between them? We calculate with this formula, and we can subtract this AB square from the BB square to get their part difference. The d square cancel to each other, and that will remain there. When you open this formula into the a plus b and a minus b, because a square minus b square is a plus b, a minus b, and I have just here written, you can see bp minus ap, because this is a part difference, and a bp plus ap, which is a formula b a square minus b square, I have written in this side. These two are from the formula. And here we consider the bp and ap, they would be equal when this point P lies at C. That means when this point reaches to the point C, see the